This is a continuation of example 2. In example 2, we showed that the change of enthalpy of some substances was 123 kilojoules, and we're going to see how that affects the temperature of water. So if that's the heat of the reaction, then we know that to get the Q for the water, we're going to take that same number and change the sign. So in other words, negative 123 kilojoules is the Q for the water. That means that all of the energy being absorbed by the reaction is being given off by the water. Okay, and so then we might think of this equation to figure out, to relate that to the temperature change for the water. And we need to make sure we put in the numbers for the water here. The thing is when we do this equation, the specific heat is in joules per gram degree C. And so that means that we need to have this Q in joules and not in kilojoules. So so you can do that different ways. But you're basically multiplying by 1,000. Okay, let me fill in the rest of this. I have 1875 grams and a T2 minus 25 for that. I'm going to change color so we can see what's going on. And then I'm going to take this number and divide it by these two. And then see that I lost right here. I see that I lost my negative sign and didn't show it there and there. And I know it should be negative because the water should have a negative Q. It's cooling off. Okay, then so I get a T2 of 9.3 following my sig fig rules for adding and subtracting. Okay, and then I can always ask myself, does that make sense? And it does, because this is an endothermic reaction, so the water should be cooling. And so sure enough, my second temperature is cooler than my first.